So when you're sketching it to flip something over, a line, what it is you just make a line that's perpendicular to the line you're flipping it over. So it's got to be at a 90. You don't want to go up to here. And then you just go straight across to the other side and put that point there. So this one, you would just kind of estimate.
Slides will be the easiest.
Yes. Translations are the easiest. So that one's a little further. Right there. Okay. So that's how you tell a reflection. Now, like I said, the vertical lines visually is easier for people to do, and the horizontal. You do have to do some though when the line is like a diagonal. If you're going to flip this over this line, this is going to flip down like this. So again, this is what I see a lot. There's one kind of just like this one on the test when we take the test. A lot of people just redraw it over here as good as best as they can. Is that a reflection? No. If you folded this, this would fold down to here. Okay? So you got to do what I just did. Each point, you got to go at a 90 degree to that line, and then you just keep going the same side across, and you find the point. It'll be right about there, just like that. There. Okay? So remember, you got to go add a 90 to the line, and then you just keep going across. Same thing when we do these on a graph. You're going to do the same thing. So the line of symmetry is also the line that cuts it in half. Sometimes things fold on themselves now. If you had a picture like this, and you reflected it in this line, like there, it's like a piece of paper, it's going to fold on itself. This piece is going to fold up to here. This is going to stay where it's at. This piece is going to fold down to there. So it's going to look like that. You guys can all picture that, right? If you folded the piece of paper? Okay?
Could we just fold the piece of paper and draw it?
You could, but your iPads don't bend. Yeah. So, yeah, if this was on your paper, that would be a way to do it. If you got to sketch it, sketch the first one, and then you could just fold it and then sketch the second one. That'd be the easiest way to do it. So here, we're going to graph, and when we do the actual test, you don't have to do whole figures, you just have to do single points, which is save some time. So if you plot this point, J is 3/8, so over 3 and up 8. We're going to reflect it in the y-axis. The y-axis is here, so all it is going to do is flip over here. So it's, you just count, it's 3 away, so you go 3 to the other side. There's J prime. Okay. K is 7/4. They're going to reflect this in the line x equals 7. So you need to remember your algebra stuff to figure out where x equals 7 is. X equals 7 crosses the x-axis at 7. Here's the x-axis, here's 7. So it'd be this line. If you reflected that point in that line, what would happen to it? It stays right there. So K and K prime are the same exact point because it's on the line of reflection. There's a shortcut. First of all, before I do that, reflections are or is an isometry. Everyone remember what isometry means? No. Doesn't change size. Okay? So, the shortcut is this. if something's reflected in the x-axis or the y-axis, there is, I could have left that one up there, I guess. Okay, say we got a point here, 2 over 4 up. Point A is 2, 4. If we reflect it in the y-axis, it's 2 away, so it goes 2 over here. So A prime is left 2 and up 4. The original A was 2, 4. So anytime you reflect, now again, you don't have to remember this, it's just if you do, it saves you a lot of time, you don't have to graph it. Anytime it's flipped in the y-axis, what do you got to do to the original one? Keep the same what? Of these two, what stays the same? The y does, right? The y stays the same. When it flips in the y-axis, the y stays the same, but what happens to these two? Change of signs. If I plotted this point here, B, that's left 3 and up 1. So B prime, the y is going to stay the same. This is going to change signs. 3, 1, which you can see, so 3 away, there's B prime. So again, you don't need to memorize it, it's just a shortcut. When you flip in the y's stay the same, it's just the x that changes. So now that you know that, if you were to flip over the x-axis, if I had this point here, 4, 2, and I reflected in the x-axis, A prime is going to be what? Which one of these two is going to stay the same if it flips in the x-axis? X is going to stay the same because it's just going to flip from here down to here. It's still 4 over, but then what happens to the y term? Change of signs. Okay? Lines of symmetry. You guys have learned that back in elementary. I'm sure you remember the butterflies, the first one you probably learned. Butterfly symmetric. In this oval, how many lines of symmetry does this have? Two. Yep, straight up and down and side to side. A line of symmetry, remember, cuts it into 2 sides that would fold on themselves. On a regular pentagon,
5.
1, 2, 3, 4, 5.
How come it shows you the answers?
Oh, yeah, they do right there. I didn't even notice that.
So,
If it's a 1, 2, 3, 4, 5, 6, if it's a
your small brain couldn't figure that out on their
8, if they're regular polygons, however many sides it has, that's how many lines of symmetry. So a square would have 4. Up, down, diagonal, diagonal. A triangle, a regular triangle, 3. Now this one is common. A circle, it has infinite lines of symmetry. Because no matter where you put a line, it cuts it in half. Now this is one where they try to fool you, like on MCA test or something like that. They'll put something like this in. First of all, a rectangle has how many lines of symmetry? 2. Side to side, up and down. And then what they'll do is they'll put like Japan's flag in there, and they'll ask how many lines of symmetry does that have?
None.
2. Here and here. So that's where they try to trick you. They put a circle in there, and you automatically think circles have infinite. But when it's in a rectangle, the only way I can cut this is like this or like this. If they had a flag like this, how many lines of symmetry would this flag have? Just 1. The only way I could cut it exactly in half is right there. You can't cut it this way because then it's not the same on each side.
I told Miss Olson,
You're telling us that there was another line sent through it.
Okay, here's point A, 0, 2, reflected in the x-axis, which means over the x-axis. It's 2 away, so you just go 2 over here. There's A prime.
Wait, X
Uh,
is horizontal.
X is the horizontal, yeah. X, Y. In your assignment, though, they're going to tell you to give the coordinate, just so that, you know. So you're going to have to say that A prime is 0 over 2 down. B is 5, 1. 5 over 1 up is B. Reflect that in the y-axis. So it's going to flip this way. So it would flip to here. It's 5 away, so you just go 5 over there. So B prime is left 5 and up 1. C is negative 4, 3. Reflect in the line x equals negative 3. X equals negative 3 crosses the x-axis at negative 3. So that's the line you flip it over. It's 1 away, so you just go 1 over there. So there's C prime, which is left 2 and up 3. And D is 4, 0. Reflect in the line y equals 2. Y equals 2 crosses the y-axis at 2. So to flip it over that line, it's 2 away, so you go 2 up there, you get D prime. So D prime is over 4 and up 4. So remember how to find these lines? Another common line that they have you flip it over, usually they're just going to be horizontal or vertical. Sometimes they throw this line in there, y equals x. Anyone know what line that is, y equals x?
0, 0.
0, 0 is a point because if y is 0, so is x.
It's the origin.
No, it's a line. This is a line. It's an equation.
Oh, nice.
There is no line.
It's like y equals 1x plus 0. Y equals mx plus b.
It'd be impossible. Well, there's a slope. There's a.
It's 45 degrees.
No,
It's a 45-degree line.
Whoa, good
It's
job.
a joke.
Y equals x is the 45-degree line like that. Because if x is 0, y is 0 because they're equal. If x is 1, y has to be 1 because they're equal. If x is 2, y is 2. If x is 3, it's the main diagonal. So, if they throw this line in there, y equals negative x, that has a negative slope. So it's the diagonal going this way. Most of the time it's going to be the x-axis, y-axis, and then they give you a horizontal or vertical line like this, but once in a while they'll throw in the y equals x or the y equals negative x. Okay, on this trapezoid, how many lines of symmetry would this have? 1. Right here. You can't cut it this way because then this side is narrower than that.
What about diagonal?
Diagonal? If you did that,
You're screwed, Lou.
yeah. If you did that, they wouldn't fold on top of each other. A regular triangle has 3, and if you had to draw them, it'd be there, there, there. And a square has 4. Straight up and down, side to side, diagonal, diagonal. That's it.
Swing your partner round and round.
Alright, so you go
If you want to have a good time.
skiing tomorrow?
Skiing?
Yeah.
Cold, don't you get it?
Skiing on wheels? Skiing on wheels. Skiing on tracks?
How you want to fall?
You know your sled's gonna break down.
I hope not. Don't even say it. 'Cause you'll jinx it. Once I jinx it, you Snapchat.
God, please. Breakdowns.
I have 3.
That's good.
George, he did.
Well, we're getting.
Oh, yeah.
Oh, really?
Getting graph paper?
Were you mad at me?
If you were much.
Yeah. I was mad when Mike corrected.
Especially if we're going on a group.
Yeah, you are gonna wanna do this on graph paper, cause it'll be easier to find your reflection point.
Me, Kyle, Houston, I think they're maybe Devin, and his brother.
Devin's coming down?
No. He's like Carter and Jordan Peterson. Yeah, he's that kid. He's that big kid.
Oh, a different.
Yeah, Catherine. He's like Carter and Jordan Peterson. Oh, he's like Kyle bent over. He's just started doing this. Oh, thank you.
What's happening?
That was a lie. Noah has underpants on his head. Noah, get down with hands off your head.
Oh, she
Can I just have that? It's really not okay. You can't. Anyways.
I gotta try it. Kind of reminds me of the
Okay.
monster.
So, the first ones are just yes or no's, just like yesterday. They're wondering, does the blue figure map onto the red figure by a reflection? So is 3 a reflection?
No.
No. Is 4 a reflection?
No.
No, this wouldn't fold on top of that. Is 5 a reflection?
Yes.
Yes. The blue would map or fold onto the red.
Are they just, so no.
Now, these are the 3 where you're gonna have to sketch yourself.
Okay.
Yes.
So, you just have to draw it as best you can, as close to it as you can. So, you just sketch it out as close to what it is on there. And then remember, when you reflect, it doesn't just slide over. Each point is going to flip across this line at a 90 degree. So this point, you just go straight to the line and then put the new point the same distance on the other side. Here, from here to here, there to there, go about the same distance across. Here. What we're doing right now, you're estimating. Estimate means get it as close as you can. So when you do 16, there's really only 2 points you can flip over. This point and this point, connect them and draw a circle around it as best you can. I know it's hard to get it great, but just sketch it as good as you can. Down here, it'll be nice just to make a graph. Put them on a graph and just say yes or no. Do what they tell you, and they're telling you the answers. They're wondering, is this the reflection after you've done it, yes or no? Okay.
Alright.